All right, so let's continue with our animation project for tonight. So we are using the elm-style-animation package in Elm, and we basically got our project template set up just before the break. So here's what it looks like, and it looks like it has some nice defaults for the duration and for the easing of the animations. So what I'd like to do is have this animate not just the size and the scale and position, but also the actual shape of what we're drawing here. So if I remember right from the demo that I saw in the ElmConf talk about this package, we can actually animate points. Yeah, cool. And it says this is used with the SVG polygon element. So let's try this out, and I think we're also going to need a function that can generate shapes for us, unless there already is such a thing, because I want to have maybe like a triangle, a star, and a circle or something like that. And in order for us to animate the shape of the circle, we'll have to actually create a polygon that has segments around the entire circumference. So let's see. So there's transformations. Is there anything about polygons? No. Geometry? No. Okay. So let's just look in here really quick. Transformer 2D. Nope. Okay. So what I'd like to do is write a little function. Hopefully this won't be too difficult. And I want a function like this. Let's call it regular polygon, which is going to take an integer, which will be the number of points, and it'll give back a list of floats. And actually, maybe before we do that, why don't we see if we can actually animate some points. So I'm going to try putting our animation.points in here, and we'll just have a list which will be 10, 0, 10, 10, and 0, 10. And I guess if we're doing this, then we'll also want to, put the translation in here. The translate, yeah. And we'll put 50-50 in there. And that'll be the base. Oh, it needs animation.length. How do we create one of those? Oh, I see. Okay. And I guess that's in pixels. Actually, I thought it was, you just left it unitless when you did SVG, but I guess we'll see. Okay, and then all these styles are now going to apply to a polygon instead of a group and instead of a circle. Okay, let's see if that works. I saw something flying around. Let's see. Let's shrink down the animation for a moment. Okay, so I'm seeing the animation, but I guess the translation, there we go. Okay, that looks a bit better. And we had to do this yesterday. The other thing I want to put on here is an HTML attributes style and set the max height to, oops, and this needs to be in a tuple. The max height will be a 100% of the view height. And we need a comma there. Okay, and then we'll import html.attributes. Okay, that looks a bit better. Okay, and then let's just make sure that we can actually animate the points in here. So let's maybe swap these. So maybe it'll go from -10 and swap this. Let's just see what this looks like. Cool. Okay, so we have a polygon that's animating. And the other thing I wanted to test out is, can we actually add an extra point here into our polygon? Cool. So it looks like the animation package just handles all of that for us. So that looks great. All right, so now let's, instead of hand coding our points, let's make this a regular polygon, and we'll have a triangle here, and then we can maybe animate it to like a pentagon or something for the moment. And then let's implement this function. So basically, I think we want to, for each side, loop through and divide the circle into equal segments and add a point for each side. So I think we'll use list.range for that, and from 0, actually I guess from 1 to the number of sides. So that's inclusive. That'll give us a list. Then we're going to map over the list, and for each index, we're going to give back a tuple of the x and y points. So the x point is going to be cosine of I, let's see, we want to take I divided by the number of sides, and then multiply that by 2 pi. And then we'll do the same thing for the y position, except using sine. And okay, then we have to convert these to floats. No big deal. And we also have to convert I to float. Okay, so let's see if that worked. It looks like it might have. So that is tiny, so let's increase the scale by quite a bit now. So we'll start at 15 and animate to 30. Yeah, cool. And let's figure out how we can put a delay in here. There's a wait, which just creates a step. Okay, cool. So I guess we can just say animation.wait and give it a time. So that's going to be in milliseconds. So let's wait 500 milliseconds when we start before we do the animation. Yeah, nice. Okay. And let's see, there's also a repeat. Ooh, and there's a loop also. Interesting. So let's try making this a loop. So we will animate wait, and then we'll wait again, and then animate it back to a triangle with the points and with the smaller scale. And, oh, I forgot a comma here. And what else did I mess up? The right side is causing a mismatch. It's expecting the right side. I'm not sure which line it's referring to. Okay. Oh, so it doesn't like this whole thing. Oh, interesting. Loop just gives back a step, not an entire animation. So then we actually need animation dot queue, and we will queue up the loop. Okay, let's try that out. Cool. All right. So that's actually pretty nice. What I'd like to do is be able to make a star shape and then also a circle. So our star, I think, is going to be very similar to the regular polygon, except this will be called points. And to make the star, we're just going to make twice as many points, and half of them will be, like every other point will be outward, and then we'll alternate between having a distant point and a near point, and alternating back and forth should give us a star. So we'll go from 1 to points times 2, and in here we will say let distance equals if I mod 2 equals 0, then we will do 1.0, otherwise we'll do 0.5, and then when we make our point, we'll use that distance and multiply it. And then sides, this should be points. Okay, so let's see if that works as our star. So let's try using a star instead of the pentagon. So we'll have a 5-pointed star. Yeah, great. And then, let's see, I guess I want to add another loop, or another segment in the loop here, and make something that's roughly a circle. And actually I want to do the circle first. So we'll start with the triangle, then we will do the circle, which is going to be a regular polygon, just with a lot of sides. So let's try 100 and see how that looks. Then we'll do our star, our 5-pointed star, and then we'll go back to the triangle. All right. I guess that sort of worked. It isn't quite transforming the way I imagined it would. But let's see. The sides of our circle look pretty smooth, which is good. So actually the way I want to do this transition is, like, right now all of the extra points in the circle are coming out of one of the corners of the triangle, and what I'd like to do is have the triangle, like the points of the triangle, kind of be evenly distributed around the circle. So I think to do that, we can just transform our, transform all of our polygons to have 100 points in them. Just with the triangle, like most of those points will be in the same position. So here's what I'd like to do. I want to have a, I'm not sure the right word for this. I'm going to call it Normalize Polygon for now. It's going to take an int and a list of points and give back a new list of points. And what I want this to do is this input list, it's going to duplicate points in this list so that the output list has the some desired number of points. So this is the target number of points, and this is the initial points, or original points. So let's see. So what we want to do is see how long this initial list is and how long our target is, and divide that. And then we'll find out how many times we need to duplicate each point, I guess. I guess that might not work particularly well if we have, like if we have 50 points here, and we want a total of 75 points. There's only certain points that we need to duplicate. So what is the best way to write this algorithm? Let's see. So we're going to loop through each point. I guess we want to figure out if, let's see. So if we take our original points, and I think we're going to need to fold over this because we're not mapping because the output list has a different number of points. And actually, let's see. We might need to do this recursively. But I'm wondering if we can do it as a fold. I guess not, because we need to do more operations than we have here. So let's see. I guess let's try it the way of my initial thought, and I think it'll actually work fine for the shapes we need. But it's not going to be ideal for all cases. So I was thinking originally that we can take the, calculate how many duplicates we need. And, oh, interesting. I'm realizing now we actually could use a map. And we'll convert this into a list of lists of all the duplicates. So let's try this for a second. So we're going to have our point, and I guess we actually want an indexed map. And we'll get our I and our point, and we'll want to list.repeat the point by some number of times. And that number of times is going to be the length. So let's do a let, because we're going to need to use this value a lot. It's going to be list.length of the original points. And then we are going to repeat this point target number of points divided by original points. And to really do this right, we would need to use I to figure out how we want to round this, depending on how far through the list we are. So let's see. So for this, we're just going to need to floor this, I think. Let's see. The definition doesn't match. The list returns a value. Oh, we didn't pass our points to the index map. And then we need to also concatenate this. And, oh, interesting. These are both integers. So let's just use integer division for right now. And what is this saying? The right side is expecting, oh, whoops, this needs to be original length. All right. And then the actual change we want to make here is we want to normalize our triangle to have 100 points in it. And I guess we also want to normalize the star to have 100 points. Well, I guess that worked. It's, oh, interesting. Unfortunately, that looks much worse than I was expecting. And also, it's quite slow. Let's see. Can we try just normalizing these to 50? Interesting. Yeah, so that's not really doing what I was hoping it would do. So I'm going to back that change out. Looks like the animation package is trying to do something more sophisticated with ordering the points in there. All right. So I guess that's not going to work the way I was hoping without a bit more effort and possibly digging into how this points animation actually works inside of the animation library. So let's do some colors animation here. And there is, okay, there's a fill property for SVG that we can use. And there's custom color. I'm not sure what that's for. And an attribute color. Okay, so I think we want to use fill. All right, so let's see. What I want for the triangle is to have animation.fill of color.red, and we're going to need to import color. And this is going to be the shape style, and I think I'm also going to want to animate the background. I guess we have to start up 2 parallel animations to do that. And the background is going to have a fill of black to start with. So we're going to have shape and background are both animation states. And then this one, okay, so we're just going to set different fill colors for the background. So let's hook the rest of this up. So first of all, we changed the name of this to shape, and I guess we're going to need to have two messages now. The docs didn't really explain that very well, but I guess because we have two states, we're going to need two different things. So then this will be the background that it's animating. Then let's go ahead and add our svg.rectangle, which is going to have, let's see, so we're going to add to it the animation render of model.background. This one was renamed to shape. And then we're also going to need some of our own attributes in here. Which is going to be svg attributes.width. That'll be 100. Height will also be 100. And we're also going to need the X and the Y, which are both 0. Okay, and there's one compile error. Yeah. Okay, so then we need a batch of subscriptions here. And we're going to subscribe to animations for both of these models, both the shape and the background. And we have two separate messages for each. Cool. So that seems to work all right. So let's see. What I want for the triangle, oh, interesting. Seems like they're starting to get out of sync though. So what I was really interested in seeing was how we can have multiple objects animated off of the same thing. And I didn't really have an example of that in the documentation here. I guess there's the demo. Oh no, this one with the morphing. I guess that starts all of them with separate animations, I would guess. Let's see, but let's take a look at the code in both of those. So here's the gears. Okay, yeah, and it has a separate animation state for each one. And oh, I see. It's only keeping one animate message, and it applies it to all of the models at the same time. Interesting. Okay. So let's try setting things up that way. So we'll just have a single animate message. When we get it, we are going to update both animation states in our model. And then we only have one subscription that we need. Oh, and that's why this takes an array. We give it multiple animation states that we are listening to. Okay. Yeah, and these are still getting out of sync, which is unfortunate, and there's not really any guidance on how to fix that. Let's see. So here, there's a there's a list of animation states, I see, and they create each of the shapes separately. Okay. And then when it switches, it just creates a whole new list and runs update. Okay. So yeah, that seems to be doing the same thing. So yeah, unfortunately I don't see any way to easily synchronize these animations better. So that's kind of unfortunate. So I guess we're just going to have to move on nonetheless. So I wanted to just get some slightly different colors in here. So for the fill color, let's animate that as well. So for the triangle, it'll be red. For the circle, let's have this blue with a yellow background. Okay, we have that. And then for the star, maybe purple on orange. And let's see. Let's do our own color here. .hsl. The hue is going to be like 345. Saturation 0.5. Brightness 0.7. Yeah, there we go. And let's see. Then the other thing I want to do is do rotation. So I think there's a rotation message. Yeah, which just takes an angle. And what was that hue rotation? Hue rotate, what does that do? Creates a CSS hue rotation filter. These stack with other filters. Huh. Interesting. I guess that's a CSS property that just changes the color of everything in it. All right. So what did we just see? Yeah, we wanted to just use the rotate property. So when we make the circle, what I'd like to do is rotate this by more than a full turn, so maybe like 1,000, and see if it'll kind of spin. Oh, and how do we make an angle? Okay, so we can actually use turns in here. Animation.turn. So let's like turn it a little more than 5.5 turns. That didn't actually do anything. Guess do we need a rotation to start with for that to work? I'm not sure. And then let's try putting another value in for the oh yeah, okay. It looked like that was working now. But interestingly, it's stuck on the circle. I guess it's hard for it, it's like slow for it to calculate the animation or something. So I can see it turning around there. Let's try increasing our delay time and see if that lets it catch up. Well, oh, and there's the star. Let's try just using a square for the moment instead of the circle, and see if the 100 points in the circle is maybe causing a performance problem. That's weird. Why is it stopping with the square? I'm not sure what's happening with this. Let's try just having it turn less than once each time. Okay, so that seems to be working better. Let's see if we can get this to be more of a circle again. Yeah, okay. That's sort of working. And then let's animate the translation as well. So we'll stick this on, and if we translate the star by maybe 75, 80, and let's increase the scale of the star as well. Yeah, so I'm definitely disappointed that we couldn't, that the two animations weren't synced up to start with, and there doesn't seem to be a way to get them to stay in sync either as we're looping. So that's disappointing. And also we were seeing some kind of weird bug when we tried to animate the rotation by more than a single turn. It was like skipping steps in the animation for some reason. But apart from that, I guess we've learned how to use this library to start with and got some basic shapes up. And that's all the time I'm going to have for tonight. So I'm going to leave it there. Thanks for tuning in, and I will see you all tomorrow for another Codevember. So have a great night.